There, it's Mrs. Flynn.
And Mr. Rops, I'm coming back. I missed
Guest
you all.
appearance. Woo! Don't get too excited. Okay, we're going to talk about criteria B and hitting the 7-8 band. And that's when students, you do justification or proof for your formula.
Right, and so we're trying to do some kind of a justification kind of scenario here.
So we're going to talk about the card house task that we just had in class as your formative. And here's our situation. We were talking about stories versus total cards. And on the first story, it takes 2 cards. Second story, 7 cards,
right.
And so on. And the first difference and second difference, we already came up with the equation by solving simultaneous equations and solving for a quadratic.
Right. But the problem is so we came up with this with quadratic equation, is how do we justify it? Or do some kind of like an informal kind of proof to convince someone that it's actually a true statement. What we're going to do is we're going to assume that somewhere along the line here, we're going to have the kth story. Okay? And I don't know how many total cards there are.
But we can kind of figure that out if we actually take our kth story and put it into our equation for total cards.
Right. So here is k squared plus 1/2 k.
Okay, so that represents the kth story.
Right, the kth story.
Well, I think we should also compare that to the k plus 1
right.
story.
If I'm going to go to the next story, this is k plus 1, that means that I will have added onto the kth story, whatever this number here is, I'm going to add on a first difference that would follow this pattern. I would have to add a first difference.
And there's no way that we would actually know what that value is because we couldn't go all the way down to k stories.
Right. So let's find out what the total number of cards would be for the k plus 1th story.
Well, we can use the same equation again.
Right. So I'm going to plug it into here. And my s, I'm going to let s equal k plus 1. Right. And so I get t is 3/2 k plus 1 squared plus 1/2 k plus 1. Now, I'm going to expand this out. I'm going to look for my kth story, because I know to my kth story I have to add a first difference of some kind.
Okay, so if we can figure out what term it is to add that first difference to the kth story.
All right.
I know that sounds a little confusing, but as we go through it,
all right, so I get
it'll make more sense.
2k plus 1 plus 1/2 k plus 1/2. If I multiply this out, I get 3/2 k squared plus 3k plus 3/2 plus 1/2 k plus 1/2.
Okay, so as Mr. Epps mentioned before, we're going to look for...
This is our key term right here. Our kth term, this is our key idea. We want to find that inside of this calculation.
Well, it's actually pretty easy to find.
Right, so I know I have a 3/2 k squared, which is this one, and I have a 1/2 k here, plus 1/2 k. So this is my k plus 1. Or sorry, this is my kth term. Okay, what's left over now is plus 3k, plus a 3/2 plus 1/2 is 2. This is what's left over in general cases. Okay, when I go from my kth term to my k plus 1th term, this is what's left over.
So that means that is the same thing as the first difference that we add.
All right, this is my first difference.
And that's here. What we add to our k term to get the k plus 1.
Right, because this is generally our kth term. This is going to be what we're going to add. And if I look at this column here, my first difference column, I can see that, well, if k would equal 2, let's say, which is...
the same thing as s is 2.
S is 2. I plug it into here, and I get 3 times 2 plus 2, and I get 8. That was my first difference to go to my next term, 3.
That's cool. So we could do the same thing if k was 4.
Right. If k is 4, then I would have whatever the next one here, and it should be, by looking at this pattern, it should be 13. So if I plug 4 into here, I get 3 times 4 plus 12. Oh, sorry.
think-
It should be 14 because
Yeah,
I'm
there you
adding
go.
3 each
There you
time.
go.
My
Okay.
mistake there. So I get 14. And so, generally speaking, if I go from k, which is this term, to the next term, I have to add this first difference, which is this pattern here, which is shown there. And that is not a formal proof, but that's a pretty good justification on the fact that this formula will work. This one up here, this one way up here, will work for every single layer of story and no total number of cards.
Okay, so there's one way you can justify.
All right.
Good luck.